Now, something else we're going to talk about in this unit that we really don't get into in terms of this structural stuff as much are metallic attractions. And I just want to briefly introduce what is theorized to occur in a metal. Okay? So in a metal, you have a whole different bailiwick. Everything's different in the metal. All right, let's remember a little bit about, and I like to tie this into the way that metal ions form. What do metals tend to do when they become ions? Metal atoms, what do they tend to do when they become ions? Huh? They become positive. So what are they doing then to become positive? They give away electrons. So metals don't hold on to those outer electrons very strongly. Does that make sense? Does that make sense to everybody? They don't hold on to those outer electrons too strongly. Right? They tend to give them up. Does that make sense? Okay. Well, in a metal, and let's just look at iron as an example. Okay, so here's an iron atom, and here's another iron atom, and here's another iron atom. So those outer electrons, they're not holding on to them too strongly. Okay, they're out there, but they're just kind of loosely held. Okay. Now, if these metal atoms are not holding on to those outer electrons too strongly, okay, what makes them stick together? What makes them stick together to make these structural things we call steel, for example, is these loosely held electrons. They become the kind of glue that holds everything together. So if iron tends to let go of 2 or 3 electrons pretty easily, but it still kind of wants them, because if it's positive, it's attracted to negative stuff. Then this metal is also attracted to those electrons because it's a positive center with those loosely held electrons. So the electrons become the electron C model, SEA, the electron C model, where the electrons are allowed to flow freely around all these iron atoms or iron ions. So they're not really atoms, they're not really ions, there's something in between. Does that make sense? Kind of, sort of. Well, this is what allows metal to form a kind of crystal structure, where these metal atoms are lined up nice and straight. But it also gives metal some unusual and really important properties, because this allows me to shift these ions over without breaking the whole structure. Because they're not attracted to, this isn't a positive attracted to a negative, they're attracted to this glue that's kind of flowing all through that. So if I take these ions and move them over here, nothing breaks. It just kind of shifts. Does that make sense? And theoretically speaking, that's what gives metal the ability to be malleable. That is, it can be bent without breaking. It's what allows you to pull it into strands like wires without breaking. What? Ductile. Yeah, the property called ductile. Ductile. Malleable and ductile are the words. Malleable means you can bend it without breaking it. Ductile means you can pull it into threads or wires without breaking it. Does that make sense? Okay. It also is what allows electricity to flow through metals, because those electrons are flowing already, aren't they? All we got to do is just shove some more electrons in this end and they start to come out the other end. Does that make sense? Alright, so this electron C model, we don't know for sure it happens that way. Not absolutely positively for sure, but it answers all of the questions about why metals behave the way they behave. Why they are malleable, why they are ductile, and why they allow the flow of electricity. And for that matter, it's partially why they allow the flow of cold and heat so easily. Okay? Everybody got that? That's called what? What?
The front row is cursed.
I know it.
No,
What's that called?
Cursed.
No, what is this called? Electron C model. SEA, electron C model. And I'm not going to get into the electron C model and what holds metals together in the structure they're held in any more than that. Okay, that's all we're going to get to in terms of the theory. But you need to know that metals do have a type of crystal structure. They have a type of crystal structure because the atoms or centers here, atom/ion centers, are arranged in a very organized way. Does that make sense? Because that's what crystals are. Organized, very highly organized. All right.
So this would not
What?
right. The metals are not organized.
They're highly organized. So that's a crystal. This is a crystal structure because they're highly organized. The metals are stuck right next to another metal atom in a very organized way. You can always tell if there's a metal here, there's going to be one here most of the time. Okay? Just like in salt, wherever you got an NaCl, there's going to be a chlorine next to it. Wherever there's going to be an iron, there's going to be another iron next to it. It's a crystal structure. Okay?